Hi, this is Matt with LSAT Cracked. In some of the previous lessons, we've taken a look at all statements, if-then statements, how to diagram them, and now you're comfortable with the idea of putting a given English sentence that represents a conditional statement into a diagram, an arrow diagram. What happens when you have two of them? You need to understand when you can and when you cannot reach a logical inference or valid conclusion from those two statements. Let's look at the only three possibilities where you're ever going to have to wonder, can I reach an inference? And let's first start with one that's obviously no good. I tell you all aardvarks are bashful and all cats are delinquent. Okay, so that's A arrow B, C arrow D. There's no common variable. There's no connective tissue between the two of those. You obviously can't reach a valid conclusion from that. So let's set that aside. The ones we're interested in are the ones where you've got two statements and there's a common variable between them, a possible link. Let's think about what that could look like. Well, you could either have the common variable 1 in the necessary condition and 1 in the sufficient condition, okay? You could have it where both common variables are in the necessary condition, and finally, you could have both common variables in the sufficient condition. Let's take a look at what happens when it's A arrow B, B arrow C. As you can probably see, the idea is that's a valid transitive link. If all apples are bruised and all bruised fruits are on clearance, we can conclude all apples are on clearance, A arrow C. Notice how the two of them literally link up, A arrow B, B arrow C. That works. Now let's take a look if the common variable is in the necessary condition. All apples are bruised and all salamanders are bruised. Okay? Bruised is in the necessary condition, but there's no required overlap between apples and salamanders. Maybe there's 3 apples, there's a trillion bruised objects, and the last 3 salamanders, the 3 salamanders we have down here, are those last 3 of the bruised objects. So there's no required overlap when the common variable is in both necessary conditions. Last one, the common variable is in both sufficient conditions. So let's say we say something along the lines of, all blue shirts are stylish. And we say, all blue shirts are comfortable. So BS is in the sufficient condition for both. And now we know that assuming the existence of at least one blue shirt, which we said with the word all blue shirts are this, all blue shirts are this, as soon as we write down BS on our paper, right, or B for blue, we immediately know what must be true. Well, S for stylish and C for comfortable. So there's a guaranteed point of overlap between comfort and style. We can therefore conclude C sum S. Some things that are comfortable are stylish, and vice versa, some things that are stylish are comfortable. Those are the only 3 templates you need to know in terms of a common variable occurring between 2 all statements.